Hello, and welcome to today's webinar when we'll be talking about the generative AI for network troubleshooting. My name is Adam Kułagowski. I work as a network engineer and I concentrate on network and system operations.
Welcome. My name is Tomasz Janaszka. I am a solution architect at CodiLime, and I am focusing on finding useful applications of AI techniques in networking problems.
Okay, let's start with the agenda for today's webinar. First, we will talk about the issues that can be solved with our POC. Then we'll go straightly to the live demonstration. The demonstration will be divided into two parts. Then we'll talk about the network solution, network overview, how it works. And then we will discuss briefly benefits and challenges. At the end, there will be QA for you. Okay, so let's start with the issues. So how the GenAI can support network operation? There are several parts. First, it can make easier to obtain network about the current state of the network. It's lower the entry barriers, so it makes troubleshooting way more efficient, and this will be talked in details on the next slide. Then it can speed up the process of documentation and reporting of the current network state. This will also be shown on the demo. And last but not least, it can support the process of creating network configuration and extend the existing network. So troubleshooting. We'll show you today a POC of what we call NetChat Assistant. It's an approach using generative AI to support network problems and network documentation. Why we decided to show you? We believe that current large topologies has its own issues, has its own emergencies, and those things can be very difficult to debug, especially by the less experienced staff. And the senior staff has already too much on their plate to support every problem that can occur. And we believe also that some aspect can be speed up, simplified, and automated, at least to some extent. So without any further ado, let's go with live demonstration. So here we can see that we have two data centers. This is a high-level design of our topology, and those data centers are connected with the external network. And this is the low-level design. More details. We can see here that we have classical spine and leaf topology with several devices, several endpoints, two gateways, two redundant connections between those data centers. What is worth mentioning here is that several devices are using different vendors. So we are not homogenic on point of the vendors. We have Juniper, we have Sonic, we have FRR. So regardless of the vendor, our solution, our POC got it covered. So this is the topology. Let's describe the agenda of the first demo.
So during the first demo, we will ask a couple of questions just to demonstrate how our AI engine, which is behind the NetChat Assistant, is understanding the network topology and how it interprets the configuration data of the devices and of the connections that are set up in this network topology.
Okay, so this is how our POC looks like. It's a classical chat interface. And let's start with the first question here. So we're asking the AI to list the devices and their details in the network. Of course, we are not using the physical devices. We have everything visualized using container labs. And there are several devices such as leaves, such as spines, endpoints, and here we've got all of them listed here. We have leaves, we have endpoints, we have gateways. And by asking the details, we've got type of device, we've got the management IP address, and we've got fully qualified domain name of that device. So this is the brief summary of our topology from the AI point of view. Let's ask a little bit more specific question next. So right now we are asking only network devices for their platform and operating system version. And here the AI has to go into every device, log into them, ask the question of the version, gather the result, and provide the summary underneath. It's taking a little bit of time, but here it is. So we have leaves, we have the gateways, we have platform. We can see CRPD, so it's a Juniper. We got FRR routing, it's an open source daemon, and we've got Sonic device as described before. So this is a summary. Now let's go with the next question. So here we're getting a little bit more specific. We are asking for the IP address of the loopback interface on one of the specific device. It's a leaf2, so we're expecting a brief response, and here it is. It's 10.992/32, and this is in line with the configuration that we applied earlier on. So this was the question, this was the generic question, and they didn't require the understanding of the underlying topology. So the next question will ask directly about that. So we are asking if the AI understand the topology it's working on. So we are asking here if there is a direct connectivity between two devices, sleeve 4 and spine 2. And yes, there is a direct connection between those two devices. So since there is, let's ask for a little bit more details about this connectivity. So right now we are asking to summarize the connectivity details between leaf 4 and spine 2 and the IP addresses on those interfaces. So here it has to log into leaf 4, log into the spine 2, ask the issue specific comments, and here got the beautiful colored response with the H1 with the IP address, H3, and you can see from the IP addresses that they share the common net mask, and this points that this is indeed the direct connectivity between those two devices. Also, we have a nice summary how they are connected in different human readable form. So this concludes the first part of the demo. Let's go back to the presentation and let's talk about the second demo. So on the second part of the demo, we'll use exactly the same topology. We'll use the left data center, right data center. However, you can see on top of it, there are two redundant links between those data centers. Redundant doesn't mean that they don't share a physical location, a single point of failure, and indeed, this is the case here. So we need to go, let's go to next slide. Okay, so here you can see that there is an excavator running, and that excavator disrupt both links at the same time. I'm speaking here from the live experience when we had exactly the same problem, two data centers, separate connectivity. However, they shared one physical location. There was some work going up there. Both of those links were severed at the same time. So this what will happen. Let's go with the agenda of this demo.
So during the demo number 2, first we just emulate the failure that Adam described. And after that, we would like to issue a couple of questions to our NetChat assistants in order to demonstrate its capability of helping the user to obtain insightful information about this failure. So I will switch now to the console and provide some commands just to emulate this failure.
Because we don't have excavator in our virtual environment, in our container lab, so we'll do the next best things. We'll issue a command that will provide 100% loss connectivity between those two data center in both direction or on those two links. So this is what happened. Now let's go back to the NetChat assistant and start asking the question. So the first question is a very generic one. We are not asking about the interface. We're not asking about the BGP. We are just asking for are there any problem in the network? Check all the devices that you have access to, all network devices, because we don't want to lose time for the endpoints here. And here we see that the AI is going through the gateways, is going through the leaves, and it's going through the interfaces, and it's gathering the output as we describe it.
Yeah, it is worth to mention here that this logic is up to our engine. So First, it take the decision which script have to be executed and on which network devices, just to gather as much as possible networking data. And of course, this question is quite generic, so it means that this is quite a lot of work to retrieve the data. Yeah, but
we have the response, and we can see that there are several interfaces in down. Let's go if there is a summary provided. We didn't ask for any, and we didn't got any. But since we are seeing that the AI has detected that there are several interfaces down, let's ask a more specific question about the interfaces itself.
Okay.
So we are asking which interfaces are down. We are asking this question in a little bit more specific manner because several interfaces are intended to be down, and we are only interested in one that they shouldn't be down. And here we are limiting the response with interfaces that has IP address assigned, and please provide the summary or provide the response only with the IP addresses of those interfaces that are down. So let's wait a little bit.
Yeah, so this is the live demo. So we are just asking the OpenAI, sending the say real data there for the interpretation. Sometimes we could have some problems with connectivity, and in fact we have two options. We could just ask another question, or we could even use much more powerful large language model. So let's.
Since we are seeing an unaccepted response time from the GTP4 Mini, let's go with a different vendor and a different AI engine and see if there is any improvement. Yes, it is. So if one engine doesn't provide us the correct answer, we can always switch to the different one, a little bit more expensive, but with faster response. And here we see how that is work nicely with every interface. And let's wait for the summary here. Okay, so here we have a response, and we have a very nice response. So instead of list of all interfaces that are down, the only interfaces with the IP addresses are provided. And here on the DC gateway device, and if you remember from our previous slides, those are DC gateways are the devices that are connecting both data center. And Team 0 is an virtual device interface that is using physical connectivity to share one aggregated interface. And we can see here that Team 0 interface is down on both of those devices. So now we are seeing what has failed. Let's ask again more specific question about the status of that interface on that device.
Yeah, we can try to switch back to this mini because it's much cheaper, 10 times cheaper than this big large language model. So and try another question.
So here we are asking for the Team 0 interface on DC gateway device on one device, one interface, and let's see what the response will be. And yes, we can go up, and we can see that the administrative status is up. So we are expecting that this interface to be up. However, the operation status is down. So this is not expected. So this is the exact output, and this is the pinpoint, this is the culprit that we'll use to provide the feedback for the second layer of support for more experienced administrator or staff to continue the debugging. So we can see that it is indeed help us to debug our problem.
And taking into account this question, we add something. So we would like that also form that our engine to format the output in tabular form. And let's see what it will do. So this is the same question to our network, but we would like to show you that some development, when you are developing the scripts, some tasks can be just moved to the LLM because it's quite good from summarizing and also formatting. So we could see the same output, but in the form of the table as we wanted. So this is another, say, a good point of such a framework that could be used when we ask the question to our network.
Of course, tabular form is for the human. If we would like to automate the AI, we can ask for the JSON as well, but for the sake of the time, let's skip that and go to the next part.
Yeah. Also, we just it is not so difficult to add the functionality when we can also talk to our network. So I will demonstrate this microphone. So I will record a command and we will see what happened. Show me vendors of leaf devices in the network. So my question was just changed into the text, and let's try to execute it. So in this option, we have the possibility to improve the text that was recorded and just execute one.
So this can be used on the mobile devices when the keyboard is very limited and it's faster to communicate with the solution using voice-only commands.
And quite simple logic just to extract the leaf nodes in our topology and ask for the vendors. If we have such a script in our engine which is registered, then we could do it.
Okay, so this concludes our demo. Let's go back to the presentation when we will go with the solution overview, what lies beneath.
Yeah, so as you could see, so the user is using the, say, chat. This is the application that was built on top of GenAI platform. And this platform is responsible for the communication with large language model. And we as developers have to also prepare some script that could be well documented to be understandable by the AI platform. And those scripts communicate with devices and retrieve the configuration data or state data about these devices.
So the documentation and the description should be in human readable form. In most of the cases, copying the documentation from the product to the script is good enough for the LLM to go.
Yeah. And when a user asks the question, the platform together with LLM is wondering if it has appropriate script for the data retrieval that is related to the question of the user. If so, it creates a kind of plan of the execution of script of the consecutive devices and is collecting the information. And next step is just the interpretation of the output and to respond to the user.
The output can be provided by the devices in the JSON, XML, on human readable. It will be all passed by the AI to provide the summary to the user.
So this is the shortest explanation how it is work. Of course, underneath this quite a lot of details. But we will conduct the quite deep, technically deep workshop on our solution at AutoCon 2 conference this November, the 18th in the morning. So this conference is organized by Network Automation Forum. It is quite a new initiative that is focusing on creation of the community of network experts, of network engineers and professionals, as around the topics such as network automation, network orchestration, and observability. So during this session, we will provide much more technical details how this solution is developed. We will talk about the details about the architecture, about the framework, about the key components necessary to build such a solution. There will be also the great opportunity to hands-on on the tool, to ask questions, to check it, also to modify a code, just to see the changes in the behavior of this NetChat assistant. So if you could, please join us during this event, much more details.
We'll be happy to talk with you there. Okay, so let's talk about the benefits and challenges that this POC or approach give us. So what NetChat Assistant, this is how we called our POC, can and cannot do. Let's start with can.
Yeah, we have 4 points. So we strongly believe that we could lower the cost of the entry, especially for the new engineers, because there is no need for deep expertise. And this solution is making, say, the retrieval of the data, of details of the network much more accessible to broader, say, number of the engineers, including those less experienced. Of course, if we could retrieve the information faster than usual, then this we could expect acceleration in debugging or inspecting our large infrastructure. And this flexible automation that we demonstrated also does not need to have very complex scripts. In fact, they could be quite simple because a lot of tasks for the interpretation, formatting, and the collection and planning what to retrieve from the network, we moved to the AI engine. As the effect, the development effort could be much lower. Also, the good point of this solution is that administrator can define and limit the commands that can be executed on our infrastructure. In that way, we could assure and limit the risk of unauthorized and harmful actions that could be taken. So this is under our control, and it depends on the developers of such a solution, which actions are permitted.
Yeah, so there is no risk that the AI will go wild and start destroying or reconfiguring your network without your supervision. So every step is being controlled and there is no risk here.
And also, finally, the good point for the organization with strict security and data residence requirements. In many times, we do not want that our sensitive data about our network is exposed to the internet. In that way, implementing the large language model on the prem, if there is such a possibility, the whole solution could be also enclosed on our infrastructure. And in that way, we are excluding the possibility to
Data leakage
outside our infrastructure.
Okay, so this was the part of can. Now let's go with cannot. So first of all, we would like to stress this out. This approach won't solve your all network issues just like that magically. No, it's a tool. It's not a staff replacement. It's make life way easier. It speeds things up, but it's still a tool. It always won't be 100% accurate. Sometimes the question can be interpreted differently from the intent of the author, so it needs to be supervised. It doesn't have to be supervised by the experienced person because even a junior will be able to correct this and ask the question in a different manner. And last but not least, this approach won't try the scripts tools by itself. The network operation teams still has to do their job, but its job will be well simplified to a simple scripts. Automation will be provided by the AI, so at least this is off their hands. Okay, let's go to the next slide about the takeaways.
So a few takeaways. We hope that we proved that GenAI-based solution can be also used for network operations, especially if we look into the future. So we could expect new releases of large language models that are much more accurate with less level of the hallucinations that could be cheaper and faster. Also, the GenAI frameworks like LangChain, LangGraph are becoming much more mature, and gives the possibility, for instance, for the parallel execution of the commands in our network. That for sure will speed up the data retrieval process, but also provides more control on the, say, plan of retrieval of network data from particular devices. So it will be in the near future. So having such a component much more mature and much more accurate, we can build such a solution also much more precise and accurate. So we also strongly believe that such a tool allows for, say, optimize or better allocation of talents. So the senior staff is usually overloaded. So having such a tool, we would like to extract the knowledge from them, ordering them to write very nice scripts and registering
Simple scripts, so they don't
Yeah.
lose too much time.
and making it, say, the knowledge available to the broader audience in our organization. And less in that way, the less experienced engineers can do straightforward troubleshooting instead of calling for senior experts. But of course, we realize that as every application that is trying to use a large language model, also this application poses some challenges. And one of the most important is the selection of large language model, just to compare the costs and its accuracy and say capability for hallucinations, etc., etc. And of course, we need to balance the cost of the LLM and the accuracy of the responses that we could gather using that tool. And this is our solution is not off-the-shelf solution, can be easily adopted to the specific needs, and either can be large language model can be fine-tuned, especially for, say, particular network operations. So there is such a possibility.
So this summarized our presentation. Let's go to the QA. We encourage you to write the question in the QA part of the Zoom. We already see that we have some question in chat. Let's start with them, and then let's go to the QA on the QA part. So the first question is, what was the problem statement in the first demo? There was no problem specifically. On the first demo, we showed that the AI can be used for the documentation process, showing what is connected to what. It can be shown to extract some information from the devices, such as qualified name, management IP address, vendor, operating system. This can be useful for searching for the security issue, or it can be asked for the IP addresses of the specific loopback interfaces. Tomasz?
Yeah, the second questions. I'm not sure if it is the question. Will we also cover use case or just the technical design? I think this is the question about the.
I think we covered it by the demo and by the description of the technical after the demo. If this is not the case, please elaborate on that later on. Okay. We'll be happy to provide you the correct answer. The next question is, can you show how the backend works in the terms of the stack, how it's built? Also, it seems to use the public LLM, so the data is not kept in private. So yes, it uses the public LLM. Is the data kept private? In this scenario, no, but as Tomasz mentioned, we can use private LLM, totally on-prem, fully isolated, or we can use dedicated LLM in public with direct contract with the provider to share only the details and keep the data public. So we'll be working on the dedicated splice of the cloud.
Yeah, and there is a question about how the backend works and how it was built. So a few questions about the frameworks. We use the Streamlit. This is the kind of framework that is joining the front-end development with the backend development. So this is very nice tool for the prototyping. And we use LangChain and Agents. And the API to the large language model. So in a very natural, but much more details we will explain during our workshop that we are inviting you.
Okay, the next question is, does it mean that the AI in the background doesn't keep the memory context of the troubleshooting session and information exchange? Yes, we specifically disable it. Tomasz can elaborate on that more.
Yeah, in fact, the process from the posing the question to obtaining the answer, this is to say one session. But if the user asks a couple of questions, there is a issue of the conversation with the user that may provide the more specific question after that. So we switched it off in this demo, but it is quite easy to do. Just in the prompt, we are introducing the answers and questions from the previous ones. But here we have to take into account that sometimes when we are gathering the information, we are limited by the, say, prompt size that we could send to large language model. So this is the one of the limitations that have to be taken into account if we think about the conversational feature of such a tool.
Also keep in mind that during the debugging, the network itself can change again several times. So it is important to work on the latest status of the network, not the history that might be inaccurate or obsolete. So the next question is
about commands, I think.
Yeah, we can go to the panel on top of it, on the QA session. Let's go with the cybersecurity question. Tomasz, do you take it on this one?
Okay, how do you mitigate cybersecurity? I would expect that most networks will have restricted and encrypted access to their M and C. Yeah, in fact, this demo is just to focus on the possibility of the interpretation of the data by the LLM. But taking into account the frameworks, many depends on how we write our scripts and how we move the rights of the user of the NetChat assistants into the scripts. So there are some, it depends on our, say, in fact, implementation. So, and also, if I could mention a little bit details, these tools, these scripts can be grouped into the, say, entities. And we building the access to NetChat assistant, we could just provide some access rights. So as a result, some users less experienced can have only access to the, say, chat, which could only use the scripts that are permitted to the user. So this is the, say, I think the basic protection.
One more thing, because maybe this is also the part of the question. It doesn't mean that the public AI was logging into our devices. No, our solution, our POC was logging to devices, issuing the command. So it was run from the inside the network. Then it was gathering the output. Then it was posting the output to the AI part and getting the response from the AI part and explain to the user. So we are already inside the network. There is no need to provide the outside access to our network. So let's go with the next question.
Yeah, how is the training done? There is no training here, in fact, because we are using large language model. So we are using in this demo quite good language model that we investigated that is able to interpret networking data. So this chat is constructed in a way that is retrieve the data from the network devices closely related to the questions, and the platform is constructing the prompt to the large language model, providing that look into this data and interpret it and do your best to answer this question. So the training is not that. We can think about the training or fine-tuning large language model if we have such a capability in order to specialize large language model to connect to our chat, just to have better understanding. We use the general purpose GPT model, but it is doing quite a good job.
Yeah, as you can see, it's debugged our problem quite well. So the next question is, can you share some quantitative metrics of the benefits you have seen by using this tool? So this is not a tool. This is an approach. This is a POC. We wanted to share you how this idea can be used, how it can be adapted to network needs, but it's not being used in our network. It's a demo, not a product.
But I think like quite good evaluation could be if you try just to log into a couple of devices and ask the same questions and try to note what is going on particular devices and try to investigate and interpret it. Maybe such a times could be just compared and yeah.
So the next one is specific AI. So I will give it to you.
Does the AI system keep context, memory of the answers it has provided for further inquiries? As we mentioned before, in this demo, no, but it could be quite easily added. Yeah. So the question is how we can shrink the previous questions and answers in order to not to take too much space in our prompt for of the next questions.
Yeah, again, what we mentioned before is that the network might change in between questions, so the previous information, previous data might be inaccurate or obsolete. Okay, so the next question is again to you.
In your experience, is there any LLM you have found better working at the moment? Yeah, this is the very good questions. We just did a quick research on the LLM that are supposed to process well data, especially networking data. And we found there is you can find in the internet net LLM, but we didn't have the chance to check it. Yeah, so it requires some time just to set it up and to check on even on our simple use cases.
Okay, the next question. This has shown the extraction of information from the infrastructure. Is there a counterpart to act into the network and send configuration command updates? Nothing stops us from doing that. We can prepare the scripts for some simple task, and we can ask the AI to provide the configuration. We try that even with the existing knowledge of the AI from the public internet. So we ask a question to the AI, assuming that this device is this vendor, how you want to configure the OSPF, and the chat assistant provided this, hey, this is a Juniper device, so the OSPF configuration will be looking like this. And here is a link to the documentation. So yes, there is a possibility. It just wasn't included in our demo.
Yeah, but we tried it. So we provided simple questions for the pinging between devices, and it's working quite well, but also changing some properties of the properties like MTU. But here during this webinar, we focus on the finding some good feature for troubleshooting.
Very simple demo to make it fluent. Okay, the next one, yeah, sounds like yours.
Have you considered integration with hyperscalers to use their LLM gateways to give easy switch point from one LLM to another as they evolve? So, as you could see, there was a switch between three large language models. Say our colleagues also tried another vendors of LLMs. So our approach is just we could select the LLM, in fact, and provide other vendors. So this is our approach. However, I do not see any problems because this GenAI, say, frameworks like LangChain very facilitates the usage of different LLMs from different vendors. So I could answer this. So there's no big problem just to exchange even during the working with the chat and to check what another LLM will respond to this particular question.
Okay, see, we seem to miss a question. What are the capabilities of the model to use an existing inventory database, CMDB, as well as updated based on the network discovery audit? So this is already done. As we mentioned, for our environment, we are using Container Lab. And Container Lab, after deployment, provides a JSON output with the topology status. So we are feeding this status output directly into our solution to make the AI better understand our topology. And in our demo, when we are asking, is there a direct connectivity, that output was used to check if there is a link between those two nodes. As we show, the AI understood the output of the container lab and responds, yes, there is a direct link between leaf 2 and spine 3 or 4, I don't remember, but it was in line with the existing topology. So yes, it can be used. Can it be updated? Since we mentioned that the output can be provided in the JSON form, I believe so.
Yeah, I do not see any problems when you would like to provide the script that is communicating with the, say, inventory database. It is just the API, so it is just up to you from which we can retrieve the data. It could also be the inventory databases or another network supporting systems. In fact, the issue here, and we would like to outline it, is just the good description of the tool, what it really provides and the kind of data that could be retrieved. So this is a very important thing here.
Okay, capability planning, I think you will answer it.
Are you also integrating performance management data as well to have some sort of capacity planning prediction? So in this demo, as you could see, no, but this is the similar question to the previous one. There is no problem with writing the script to the, say, performance management or to the system who is having the data about the performance in the network. This is the API. You are writing the scripts and you are responding, for instance, what is the, say, traffic on this particular interface. And you could be able to obtain such information, fresh information to your question.
Okay, the next question is, how did you handle different vendors' CLIs? Well, since we've been using Sonic, Juniper, and Feather, and they are using a different approach, at least Juniper and Feather/Sonic, so we provided several scripts describing in human language, this is the script for the Juniper devices to extract interface or a BGP status and the output and the CLI command that is going to be used. And then the AI understands that now it's logging into the Juniper device, so it will find the script for the Juniper device for the specific task and then use it and to extract the information. So this is mostly offloaded to the AI in several parts.
Yeah, and another possibility is just to write a script, show interfaces. And in the script, you just call another script, just what is the vendor of this particular device, and provide appropriate command. So this is also a quite flexible approach here. But as Adam said, it could also be a script for the vendor and another script to find the appropriate script for retrieval of the interfaces for this particular vendor. And this could be part of the logic that is AI engine is providing.
Okay, so did you use netconf YANK unified modem and parse JSON output? No, we used classical SSH. So it was going SSHing into the machine with some account. It can be predefined or can be tied to the end user. And then it was gathering the output of the specific commands extracted from the documentation directly. So the show interfaces, show BGP summary, those is pretty basic command. And you can see even with the basic command, you can do pretty advanced debugging. And then it's working out the output. So yeah, we use SSH, but nothing stops us for getting that same data from the different API.
Yeah, if it is easier and better, so there's no problem on that.
What was the input in the demo one? What measures were taken to prevent the hallucination?
Okay. What was the input? So the input was the question and the network and the set of scripts that could be used to retrieve the data. And to reduce the hallucinations, there is a quite straightforward approach for crafting the prompt to the LLM, because the prompt is looking like that. Having such a data that we are retrieving from the devices, so these are the real data, answer most questions. So we are just instructing the LLM just to take into account only those data. We are not asking him about the data that was learned. We just ask them to interpret them. So it is much harder to hallucinate in such a if you have such a prompt to the LLM. So this is the one of the approach that is trying to reduce the hallucinations. But sometimes it happens. For instance, when the tool has two sources of the same data. And we notice that if some kind of data was taken from the inventory and was not, say, up to date, so sometimes in the logic we observe that they did not ask the device for the fresh data. So this is like a kind of the source of the potential hallucinations. But in general, the crafting properly the prompt is the crucial here.
I'm curious if you can answer, tell me interfaces which went down in the last hour. It's a complicated question. So some CLIs provide the answer in the show interface output, how long it's being down and how long it's being up. And in such case, yes, of course, it can be used and it will extract the type of information and try to answer your question directly. However, some providers doesn't show that information. It just show it's up or it's down. There is no history. So we can either query at some interval and record, or we can parse the logs, or if there is a response in that show interface command, we can use that.
Yeah, I think this is the quite good questions because the question how the LLM is dealing with time in general. So of course, if we are gathering the information about the interfaces, there is a place, there is a feature, say property, saying that this interface was down. So I'm not sure if such a question we will have good answer on that, but during the testing we ask what are the interface that was recently done. So in that way, maybe, yeah. But this is the question of for the interpretation of time-related data, and I know that sometimes there could be a problem with that on the LLM. So very good question. So I think that this person is know this technology quite well.
Do you need to give CodiLime or Lang LLM the full access of the database and full control of the devices? No, specifically not. We are just providing the LLM or the solution, not the LLM directly, but the solution to specific commands, and it won't go outside of those commands. So if there is a command from the ISIS protocol, BGP protocol, and we ask for the OSPF, then most likely we won't get any proper answer, or we might encounter hallucination because there are no such tool for the AI to use. So this has drawbacks, of course, because we are limited what tools can use, but it also is a fail-safe. So it won't go rogue and it won't go with a strange question that can either saturate by the extensive debugging or even reconfigure the network if you give it some power to do as well.
Yeah. Are you using any vector database for this use case? This is a quite good question. The simple answer is no. For our use cases, it was no such possibility. But imagine the situation when the number of the devices is quite huge, and we are collecting the data from the devices, and we exceed the prompt size to the LLM. So we are losing a part of the data. So the answer could be, say, not very good in simple words. But the vector database can be then used just to try before sending the final question to the LLM with all this data, just to shrink those data to select necessary data to answer the question. It is not easy, but such a vector database could be used for that, just to limit the data and to properly select the data that are finally sent to the LLM in case the size of the data is huge.
So the next question is, do you have specific prompts on the keywords predefined, or it can take any prompt from the chat interface? It can take any prompt. And if you are going to the AutoCon, we'll be having a live demo there as well, and we'll be doing a workshops, and we invite you to ask any question you would like and see the output if this is in line what you would expect. So there is no limitation. You can write whatever you would like there.
And also we will explain, because the question asked by the user is the one point, but the engine is changing this prompt and is extending this prompt by additional data. So you will have the possibility how this prompt sent to the LLM looks like, and the question of the user is usually this quite small part of it.
So the product seems to be based on asking question and getting answer. Why doesn't it integrate directly with the monitoring software or device and list possible problems for the user? Well, nothing stops us from doing that, but this approach will be beneficial and we can use it, but it will be also limiting to some cases that can be detected by the monitoring software. And no monitoring software will predict every type of the question that can be done. So user, a person, a human is the most flexible one. And we're giving that person the full power of the solution to provide the exact answer what he is looking for. So we believe it will benefit more, but again, we can go both ways and speed things up.
Yeah. In the meantime, I just showing you the some solution internals, and there is one point here that we could write the scripts not only to the network devices but also to network support systems. So it is up to us which scripts will be provided to the solution, and in that way, what type of data we could gather not only from network devices but also from the bunch of network support systems like performance monitoring and etc.
Okay, so it seems that we have time for 2 more questions. So let's go through them. Have you tested this approach in any troubleshooting scenario where the input was a network incident? Did you achieve any good results? Well, we believe that the second demo, we try to show that scenario on the second demo when we issue the link separation on the 2 physical links, and we try to debug it. So yes, it can be used. We think so. It can be used for network debugging for the real troubleshooting scenarios. And yeah, we think we can go that way as well.
Why don't you open source this POC?
Mostly because it's POC and it's not a quality code level we would like to share. However, we invite you to the AutoCon when you will get the look for the internals for the code, and you will be able to adapt and extend that code by yourself and see what will happen.
Is model based on response received? Example, operational data. Have you tested write actions via model or specific custom scripts matching criteria? I think this is the question for the separate webinar, but I can imagine that we first ask the large language model, for instance, for some commands that could be executed on particular script or particular device. But this will require just to write a script that is allowing to put any commands to the device. We think that it is quite possible, and perhaps we will check it in the future, but I'm not sure. It is very dangerous. So from the security reason, it might not be a good approach.
Okay, so this concludes our question. Thank you for staying with us. Thank you for watching. Thank you for listening.
And thank you for questions.
They were excellent. Thanks you. Bye.
Bye-bye.